Welcome to 3.1, the derivative and the tangent line problem. After today's lesson, the goal is for you to be able to find the slope of a tangent line to a curve and a point, use the limit definition to find the derivative of a function, understand the relationship between differentiability and continuity. All right, so this is the first big step in actually doing calculus problems. Derivatives are one of the main aspects of this class, and once you start getting the hang of them, they'll be easy, right? We're going to start with how they come about and get through them as we go. All right, so first thing, what is the tangent line problem? Now, a little history lesson here. Calculus grew out of four major problems in European mathematicians were working on, okay, during the 17th century. Okay, so a long, long time ago. So, like 400 years ago, plus. All right, tangent line problem. All right, way to solve those problems is using derivatives. Then they said, okay, now we have a problem measuring velocity and acceleration. Let's use something called integration or integrals. Minimum and maximum problems. Well, we could do problems like that using graphing. And then finally the area problem, right? Area under a curve. All right, that also is using integration. Now, each problem involves a notion of knowing what limits are and calculus together, the combination of the two. Okay, now, here's the deal. All these problems that they pretty much had to solve involve two subjects, engineering and physics. All right, so science, engineering, physics all go hand in hand with calculus. That is the main people that use this class, okay? If you're gonna be like a teacher, great profession. I like it, other people like it. If you're going to be another profession that I can't think of right now, that doesn't involve math, maybe a psychologist, sociologist, all right? You don't need calculus. It's good to know, makes you smarter, but you don't need it, you don't use it. Mostly scientists, engineers, physics, science, are the people that use calculus. Anyway, getting off my tangent that I just went on. Comparison of tangent line and a secant line. Now there's two different types of lines you guys should know. They both deal with curves. You did this in geometry, dealing with circles. Is a tangent line and a secant line. First one is a tangent line. That's a slope with one point. Now, if I have this nice parabola down here, point P right here would be my point of tangency. That's where the tangent line is going to hit the curve. Now, it only hits the curve at one point. That's how a tangent line works. The second one is a secant line. It's not a slope with one point, but a slope with 2 points. Now, there's two important things about a secant line. Your first point is going to be your point of tangency, and your second point could be any point on the curve. Okay, it doesn't matter where it is. In this case, I have it right here, so that's my secant line. All right, now, depending on where I move the secant line, second point, the secant line is going to change. The tangent line is always that tangent line at that point of tangency. If I move the point of tangency, the tangent line changes, but at that point, it never changes. Now, breaking down what a tangent line is pretty simply. A tangent to a circle. This is something that you've done in geometry. I've taught it, like I said before, for 15 years, I remember. When you have a tangent line to a circle, it's perpendicular to the radius. The radius is the distance from the center to a point on the circle. So when you have a line that's perpendicular to it, that at the point of tangency, that's how you find your tangent line. Now, when you're dealing with a tangent line to a curve at a point, all right, there is no radius here. So what you're pretty much doing is you're drawing what the slope of this line is doing. Notice what's happening with this curve. It's going up, positive slope, positive slope, gets to P, and then starts negative slope. So this slope right here is 0, it's horizontal slope. Right here, your slope is going down, so your tangent line is going to go down. It goes through the line. Right here, your slope is increasing, 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 still increasing. Hits it right there. That's your tangent line. All right, got it? And it can cross through the other line in more than one place. But it bases it based on your point of tangency. That's it. Now, Secant line. We're going to bounce back and forth with your tangent. Secant. You could find the slope of a secant line. You guys remember what slope is? Slope is rise over run. So I gave you a bunch of stuff over here, and I'm going to explain what all this means. First thing, your slope is your change in y over change in x, right? So right here I have a point. My point is c f of c. So this is your x value, this is your y value. This point is c plus delta x. Okay, I changed the x, so it's c plus delta x. So its y value is f of c plus delta x, meaning I just plug this into the equation to spit out my y value. Okay, that's why this point right here is c delta x, f of c plus delta x, and this point right here is c, f of c. Got it? There's your 2 points, your 2 secants. Now, when I do y2 minus y1 over x2 minus x1, which is how I find the slope of a secant line, I'm going to say this is my second point and this is my first point. So y2 is, right here my y, f of c plus delta x minus y1, f of c, over x2, c plus delta x minus x1, which is c. Okay, now, we stated before the distance between these two is f of c plus delta x minus f of c. So that stays the same. But right here, c plus delta x minus c, what happens to these c's? They cancel out, meaning the distance right here is just delta x. So right here, you're given the formula for the slope of a secant line. So you can find it every time based on 2 points. And all you're really doing is this formula right here. Got it? Good. Perfect? Hopefully. Let's try an example out. So right here, you have a purple curve, and you have this green secant line going through it. The 2 points are 2, 3, and 12, 7. Now, can you find the slope of the secant? Go. All right, now let's look. F of c plus delta x is my y2. That's 7. F of c, 3. So I'm going to do 7 minus y1, 3. Okay? C plus delta x, my x2 is 12. Over 12 minus c, which is 2. 7 minus 3 is 4. 12 minus 2 is 10. 4, 10. Reduce. 4 over 10 divided by 2 with 2. 2/5. And that's my answer. Whoa. Thought I boxed it. See? Yes, it's easy. No, it's not going to stay that easy. Definition of a tangent line with slope m. So we did secant line. That's easy because that's 2 points. Tangent line only has 1 point, though. So the way you can represent 1 point is delta x, the limit is delta x approaches 0. That means your change in x pretty much is 0. Okay? But it's just a little teeny bit. All right? That way you technically have 2 points to use, but those 2 points are pretty much 1 point because they're right on top of each other. So the way you can do this is delta y is, as we said before, f of c plus delta x minus f of c, right? And it's over delta x. Now the problem here is delta x is approaching 0, meaning if I plug 0 in here, my answer would be undefined. All right? So I'm using my secant line to find this. The only difference between the secant line and the tangent line is this one, it's delta x is pretty much 0. It's approaching 0. Not actually 0, almost 0. We're using limits to solve calculus. The line passes through CF of C and has a slope m. That is your tangent line. So this is the real point, and this point right here is like kind of a point. C is the, what value do we say the C was? Your x value. And f of C is your y value. y2 minus 1 over x2 minus x1 equals delta x over delta y. Now delta x just means change in x over change in y. Those of you guys going to college, you'll understand delta based on fraternity row, sorority row, if you live there, and if you join the fraternity. Greek letters. All right, so find the slope of the graph f of x equals 2x minus 3 at point 2, 1. This is a simple graph, I know, because it's just the slope's the same everywhere. I could go give you the answer. Oh, mx plus b. Oh, the answer's 2. But let's just, I want to start you easy. Now, c. What is my c? It's my x value, so my c is 2. F of c. My y value, so that's 1. Good so far? F of c plus delta x. Now, what is that? It's f of, what's c equal? 2. So it's f of 2 plus delta x. Now how can I actually find that?
I don't know that.
No, well, my echo doesn't know, but I'll tell you. 2 plus delta x, you just take and you plug it into the original equation, okay? So you're going to take 2 plus delta x and plug it into 2x minus 3. So it becomes 2 times 2 plus delta x minus 3. Your x here becomes this. That's how you type in an f of something. Distribute the 2. 2 times 2 is 4, plus 2 delta x minus 3. Combine like terms. 4 minus 3 is 1. So my answer is 1 plus 2 delta x. And that is what my f of c plus delta x is. See? You found it all just from this one point. Now I'm going to type everything into this equation. This gets replaced with that. F of c gets replaced with the 1. Delta x stays delta x. Now watch how this magic works. What is 1 minus 1? Cancels out and becomes 0. So you're left with the limit as x approaches 0 of 2 delta x over delta x. Now delta x is its own variable, so you can cancel them out. So they cancel out, leaving you with 1 over 1, so the answer is the limit of 2 as delta x approaches 0. Now watch what happens. If I plug the 0 in here, my answer is undefined, right? Now what is the limit of 2 as delta x approaches 0? It's just 2, and that's it. Done. All right? Awesome. Ready to move on? Let's move on. Find the tangent lines of a function. Now, I made 4 rules. I don't even know if this is how the book says, I forgot. But this is what I used to always put on my board to make things easier. First thing you want to do is you want to find c and f of c. That is, your c is your x value, your f of c is your y. So you're given a point. Whatever the first point of the point is, your x, that's your c equals that. Whatever's your second thing, that's what f of c equals. Easy enough. Second thing, you find f of c plus delta x using your c and using the original equation. So you type in whatever c is, say the answer c was like 6, you would do 6 plus delta x, you plug it in for x in the original equation, you do your algebra, and you spit out an answer. Alright? So you plug c plus delta x into the x of the original equation. Number 3, you're going to plug f of c and f of c plus delta x into the equation, f of c plus delta x. So this will be a formula minus f of c, which will be a number, right, over delta x, which will be delta x. You reduce, usually you cancel some stuff out up here. You take out usually the delta x's, because if you don't, you'll be in trouble, and you solve. So f of c should always cancel out. It should be somewhere in this equation. You're going to end up dividing out a delta x. All right, and then you're going to plug in 0 for delta x if any are left over. They shouldn't be left in the denominator. There should be maybe a couple left over in the numerator. When you plug in 0, whatever's attached to it just goes away, and then you solve with whatever you're left over with. Follow these rules, you'll get it every time. Ready to go? Apply these rules? Of course you are. Find the slope of the tangent lines to the graph f of x squared plus 1 at the point negative 1, 2. This line right here. Now, if I change my line, if I change this point, my actual slope's going to change. So it's important that we do this. So, number 1, what is my c? My c is negative 1. What's my f of c? 2. Right? Anyone here should be able to find c and f of c like that. F of negative 1 plus delta x. All right, so we're going to take our c, which is negative 1 plus delta x, and we're going to plug it into this equation. So x becomes negative 1 plus delta x squared plus 1. This you have to FOIL. This is technically negative 1 plus delta x times negative 1 plus delta x, because you're squaring it, plus 1. A lot of people forget that. When you square things, you multiply by itself. That becomes 1 minus delta x, which is minus 2 delta x's, and then plus delta x squared. Delta x times delta x is delta x squared plus 1. They combine. 1 plus 1 also combines, leaving you with 2. 1 plus 1 is 2. Minus 2 delta x's plus delta x squared. And that is that. So I'm going to take this piece right here, plug it in for that. I'm going to take my 2, plug it in for that. I'm going to leave my delta x here. Now, as I said with the rules before, this usually cancels out. Look at that. 2 minus 2 cancels out, leaving you with minus 2 delta x plus delta x squared over delta x. Right? Minus 2 delta x plus delta x squared over delta x. cancel out a delta x, and take out one of these two. So this becomes negative 2 times 1 plus, there's still a delta x over there, and divided by 1, so you just don't need to put a placeholder. As I said before, you plug in your 0 for your delta x, which is okay because it's in the numerator spot. Negative 2 plus 0 is negative 2 as an answer. All right? That's all there is to it. Once you get the hang of these, they're easy. All right, now, we're going to change this up. Oh, wait a second. I don't think I like this. You know what? I'm going to tell you this. I don't do this in class usually. Another way to do this, there's another method. I could say, oh, wait. You don't want to do it this way. I'm not going to go with the c squared way with you. 2c, 2 times 0. You want to do the c way? If I do this using c as a constant, I don't like this way personally. What you could do here is, you could say 2c is 2 times 0 is 0. That should have came last. And then when I use this point, I get negative 2 as an answer. I don't, like I said, usually go through this one, but I'll show you anyway. C is just c, all right? F of c is c squared plus 1, all right? Just plug in your c for x squared, so c squared plus 1. F of c plus delta x is just c plus delta x squared plus 1, all right? Sorry, I had to think of how I had to do this. I expand this.
I'm not sure.
C squared plus c delta x plus c delta x is 2c delta x. Delta x times delta x is delta x squared plus 1. Okay? This is why I don't like this method. I'm just going to show you though because it's a video. You can fast forward if you don't like it. Take this whole thing minus f of c over delta x. C squared minus c squared cancels out. 1 minus 1 cancels out. F of c still cancels out. Leaving with 2c delta x plus delta x squared over delta x. Delta x's cancel out. One of these two cancel out, leaving with 2c. Delta x's the limit as delta x approaches 0. This goes into a 0, leaving with your answer is 2c. Now, the way you would use this method before we said our point was c comma f of c, right? So now you can just take whatever these answers are, all right? And this is my c here, right? So at this point, my slope would be just 2 times 0, which is 0. At this point right here, it'd be 2 times negative 1, which is negative 2. All right, if I pick the point here, 1, 2, all right, my slope here would be 2 times 1, which is 2. All right, if I pick this point right here, 2, 5, my slope would be 4. All right, so if you have multiple points, you may want to use the C method. You really don't have to. Throughout the years when I taught this class, I kind of go through this one a little quickly because it confuses people more. But you can. All right. Oh, this is the rule we said before. The reason it happened again is because I did it new class, new day. All right, in case you're wondering what the rules were, these are the rules we just used, right? You good? Awesome. All right. Let's go. Find f of c and f of c plus delta x. And then b is find the tangent line. F of c is what? Negative 2. Oh, sorry, c is negative 2. F of c is negative 14. F of c plus delta x, I take my 2, I plug it in here, so it's f of negative 2 plus delta x, which is plugged in here. 7 times negative 2 plus delta x, negative 14 plus 7 delta x. That's A. B is find the tangent slope. This goes in here, this goes in here, and it's all over delta x. Negative 14 minus a negative 14 is negative 14 plus 14, cancels out. 7 delta x over delta x's, the delta x cancels out. Leaving with the limit of 7 as delta x approaches 0. There's no delta x to plug a 0 into, so your answer is just 7. Alright, if you want to check your answer, y equals mx plus b, m is 7. Got it? Alright, next one. C is 4. F of c is negative 2. F of c plus delta x is f of 4 plus delta x. Negative 2 times 4 plus delta x plus 6. Negative 8 minus 2 delta x plus 6. Negative 8 plus 6 is negative 2. So your answer is negative 2 minus 2 delta x. Take this and plug it in there. Negative 2 minus a negative 2 becomes negative 2 plus 2, which cancels out. Negative 2 delta x over delta x. The delta x's cancel out, leaving with limit of negative 2 as delta x approaches 0 or negative 2. Alright. You all good? Awesome. Ready for 2 more? Number 6. Gave you a little expansion hint there. Alright. C is 10. F of C is 97. F of 10 plus delta x. 10 plus delta x squared minus 3. If you want to use this formula, you can. 10 squared plus 2 times 10 times delta x plus delta x squared. It gives you 100 plus 20 delta x plus delta x squared minus 3. 100 minus 3 is 97. Alright, 97 plus 20 delta x plus delta x squared. That minus 97 over delta x, 97 minus 97, cancels out. 20 delta x plus delta x squared over delta x. Take one of these two away. Take both of those away. 20 plus delta x becomes a 0. 20 plus 0 is 20. Right? So at point 1097, this graph has a slope of 20. Seems pretty easy to me, doesn't it? All right, you're due now. 3.1a. What's your f of c? Negative 91. F of negative 5 plus delta x. Negative 3 times negative 5 plus delta x squared minus 16. All right, 25 minus 10 delta x plus delta x squared. All times negative 3. You have to make sure you square this right here before you multiply by negative 3. Negative 75 plus 30 minus 3. Negative 75 minus 16. What's that? Minus 80 minus 91, I think. Yep, negative 91, 30x squared minus 3 delta x. This minus your negative 91 over delta x. Negative 91 minus a negative 91 cancels out. 30 delta x minus 3 delta x squared over delta x. Cancels. Leaving you with 30 minus 3 delta x. Okay. 0. 30. Right. That's it. More problems? Of course we can do more problems. Anything for my favorite classes. F of C, 0. F of 2 plus delta x equals 2 plus delta x cubed minus 8. What does this mean? Well, this is the cubed little formula. It's always good to know these. A cubed is 2 cubed plus 3 times 2 squared times delta x plus 3 times 2 times delta x squared plus delta x cubed. Alright? The expansion formula works better. Otherwise, you have to multiply 2 plus delta x times 2 plus delta x and then take that answer and multiply by 2 times delta x. 8 minus 8 cancels out, leaving you with 12 delta x plus 6 delta x squared plus delta x cubed. This minus 0. Oh, the 0 just canceled out because it's 0. Cancel out 1. Cancel out 1 of the 2. 1 of the 3. Leaving you with 12. 6 delta x squared. This becomes 0. This becomes 0 squared. 12 plus 6 times 0 is 12 plus 0 plus 0 squared. So 12 plus 0 is 12. Wow, that's easy, isn't it? All right, here's the homework problem. I don't know why all these things are thrown around. I forget the order I gave them in. All right, at the point, f of c. F of c is 5. F of c plus delta x. F of 2 plus delta x. So 2 times 2 plus delta x squared minus 3. Okay, you can use the squared one. A squared plus 2ab plus b squared. 2 squared plus 2 delta x plus delta x squared is 4. Plus 4 delta x plus delta x squared. Distribute 8, 8, and 2. 8 minus 3 is 5. 5 plus 8 delta x plus 2 delta x squared. This, minus 5 over delta x. 5 minus 5 cancels out. 8 delta x plus 2 delta x squared over delta x. Take out a delta x, take out a delta x, take out one of those 2 delta x's. 8 plus 2 delta x, 8 plus 2 times 0. 8 plus 0 is 8. All right. Any questions? Good. Now what we're going to do is go on to the derivative of a function. Now we're getting to the fun stuff. $50 minutes. Nice. Derivative of a function, part 2 of the lesson. F of x equals the limit of f of x plus delta x minus f of x over delta x. So what changes? The only thing that changes when you find the derivative of a function as opposed to the derivative of your tangent line is your c's become x's. That's it. There are 5 notations that are used. 3 are common, 2 are uncommon. F of x is your x and your y. Your first one is f prime x. That tells you you're finding the derivative of something. The second one is dy dx, the derivative of y in terms of x. The second one is you just do y prime. Some people are lazy because f of x is the same as y technically. Then you have d dx of f of x, which is technically like d dx of y. And then finally this last one, which you don't use that much, d subscript x of y. This means you're finding the derivative of x in terms of y. That one is the only day you can see it. I didn't make, famous mathematician made a bunch of rules here. I just simplified what the rules mean. It's called the derivative of y with respect to x. Okay, so you find the derivative of y, but you're doing it with respect to x. So what that means is, the limit of delta x as x approaches 0 of delta y over delta x. Pretty much your slope, but your x part of the slope is so small to 0, so it's like a tangent line. F of x plus delta x minus f of x over delta x, and that equals f prime x. So that is your derivative formula. 5 simple rules. First rule, find f of x plus delta x. How do you do that? You're going to plug x plus delta x into the x part of your function, and you're going to expand it and reduce it. Second thing, find f of x. How do you do that? It's in your problem. It's given. It's the y value of your original problem. Plug it into the equation. F prime x equals the limit of delta x approaches 0. F of x plus delta x minus f of x over delta x. This part goes here, this part goes here, and delta x goes on the bottom. Then what you're going to do is you're going to simplify. Once again, this usually cancels out, and you can cancel out some delta x's, and you plug in 0 where any delta x's remain. So you're going to, first thing you do is you subtract and cancel stuff out. Second thing, you divide everything by delta x. And the fifth step, we'll do that with the other one. You're going to plug in 0 for anything that is left with a delta x on it. Goes away, and then you solve. Got it? Can you handle it? Same thing we did before, we just changed some stuff. So, look at this. I made you such a nice little setup here. First thing, halfway through the lesson to do it. Find f of x plus delta x. So, how do you say that? Take x plus delta x and plug it in for x. 3 times x plus delta x plus 10. Distribute 3x plus 3 delta x plus 10. Nothing can be combined. Find f of x. Uh-oh, there's no point. What's f of x? It says it. F of x equals 3x plus 10. It's the original equation you're given, silly. That's it. Ugh, ooh. Sorry, my hair got in my eye. This goes here, this goes here. So, 3x plus 3 delta x plus 10 minus 3x plus 10. 3x minus 3x cancels out. 3 plus delta x stays. 10 minus 10 cancels out. All right, if you're left with, now, let me tell you a little hint here. 3 delta x over delta x. See how the delta x's cancel out, and the limit of 3 as x approaches 0. Your answer is 3. Good. If you're, everything that's left in the numerator should have a delta x attached to it. If you're left with just a number up there, you mess something up, you better go back and fix it. All right? Not all the time, but the majority of the time. Got it? Awesome. All right, now what we're going to do is you're going to do it on your own. So why don't you try it on your own? Okay, assume you did it. Let's see what you guys answered. First thing you're going to do is you're going to find f of x plus delta x. So you're going to take your x plus delta x and plug it in for the x. So it becomes 2 times x plus delta x squared minus 4. Now, here's something that should be very important for you. You should try to remember, anytime you squared x plus delta x, this will be your answer. It's x squared plus 2x delta x plus delta x squared. Every single time. So anytime you see this when you're finding a derivative, you just replace it with that. I would write it down somewhere. It makes it easier for me. So this gets replaced with this. You're going to distribute the 2. 2x squared plus 4x delta x plus 2 delta x squared minus 4. Nothing cancels. Now your f of x is your original equation, 2x squared minus 4. And now what you're going to do is the red minus the blue. And now guess what? Just like I told you before, 2x squared minus 2x squared cancels out. What a coincidence. Oh, I got a minus 4 minus minus 4. The f of x cancels out, as it should every time. All right, so these don't cancel out, so you're left with them. 4x plus delta x squared plus 2 delta x squared. 4x delta x plus 2 delta x squared over delta x. Take a delta x out, take that delta x out, take one of those two, leaving you with 1 delta x. The limit is delta x approaches 0 equals 4x plus 2 delta x. The 0 goes in for your delta x. 4x plus 2 times 0. 4x plus 0 is 4x. Voila. And that's your answer. Any questions? Should be. Now, this 0 goes in for the delta x, not the x. The x's all remain x. Don't make that mistake. All right, so try problem number 11, but it should have been your homework problem. All right, step 1, find f of x plus delta x. You're going to take this, cube it, plus 2 times this. Okay, so you put it in for every x. This cubed, we said before, was a cubed plus a plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. All right, you can replace this with this. Every time you see this, it becomes this. So just write this down if you don't remember the formula, okay? So I'm going to take this part, replace it with all this, plus 2x plus 2 delta x. Now, when I look to combine like terms, okay, 2x's, okay? None of these have an x, so I can't combine anything there. Delta x. Nope, that's an x squared delta x. This is your final answer. Nothing here combines. And then your f of x is just your original equation. All right? So now this first part is going to be this whole entire thing up here. Looks like a lot, really isn't that much, minus this. This whole thing minus this. Watch this. Work backwards. X cubed. It's going to cancel out somewhere. X cubed. 2x. There's a 2x. Nothing else can cancel out, so you're left with 1, 2, 3, 4 pieces on top and a delta x on bottom. Notice they all have some type of delta x attached to it, right? So now here's the key. Cancel it out. All of them go away. One of these 2 leaving with 1. One of these 3 leaving you with 2. And all of that one and all of this one. So your final answer before you plug in your limit is 3x squared plus 3x delta x plus delta x squared plus 2. Anything with a delta x becomes 0. So 3x squared plus 3x times 0 plus 0 squared plus 2. These become 0. So your final answer is 3x squared plus 2. And this is the derivative of that in terms of y. And that's it. You're finding derivatives. Now, derivatives, when you find a derivative, you'll be finding an equation. And now, if I wanted to find the slope of each one of these, I could just take whatever x value from a point is and plug it in for x, and it'll give me an actual value. But we're not going to do that yet. We're just finding derivatives. Got it? Seems pretty easy, right? What do you do now? Go! Sorry for the go on. All right. You should be done. That goes in for that. You're going to square this. Now we remember the squared. X squared plus 2x delta x plus delta x squared is what this guy becomes. Negative 5 times that plus 6. Negative 5x squared minus 10x delta x minus 5 delta x squared plus 6. F of x is the original equation. All right? You're going to take both of these and plug these in. Technically, you don't even have to write this. You can just use it from there. But I just like to write it so you guys see what it is. This stuff minus that stuff. Remember, this should cancel out. Negative 5x squared, look for one over here. Those are the ones that cancel out. oops, sorry, negative 5x squared, negative 5x squared. Delta x squared is not the same as x squared. 6 minus 6, good. So I'm left with negative 10x delta x minus 5x squared over delta x. Cancel some stuff out. I'm left with negative 10x minus 5 delta x. Take the 0, plug it in. Negative 10x minus 5 times 0. And my final answer is negative 10x. All right. And that is all you had to do. You ready for another example? This is pretty easy, right? I think so. All right. Using the derivative to find the slope at a point. Now I'm just going to add in a little bit extra. We're not going to be tested on this, but it's always good to know more than we're going to be tested on. So find f prime x, that means find the derivative, for f of x equals x square root of x. Then find the slopes on the graph at the points 1, 1, and 4, 2. This is what I was alluding to before. I didn't really get into it, but I was alluding to it. First step, find f of x plus delta x. That's easy. It's the square root of x plus delta x. Find f of x. Square root of x. Step 3, plug into this equation. Square root of x plus delta x minus square root of x over delta x. Now, that's not good. What do we have to do? We don't want to have those square roots there, right? Because we're going to have to get rid of this delta x. So what can we multiply this by? Think back to like a couple lessons ago to get rid of these square roots. The word begins with the C. Conjugate. So we can multiply this by x plus delta x under the square root plus delta x divided by the same thing. Notice this was a minus, so we put two pluses. Multiply these guys by each other, guess what we get? The radical goes away. All right? Then you get plus delta x times this minus delta x times this, right? And then this times this is minus x. Two middle pieces in a conjugate always cancel out, leaving you with an x minus x. That cancels out, leaving with you just a delta x on top, divided by delta x. And then on the bottom, you still have the stuff you multiplied it by. Why was this important? Look what we could do. You can cancel these out. Now, when you cancel this out, you still need a 1 as the placeholder on the numerator. So it's the limit of delta x approaches 0 of 1 over this stuff. But now I can plug my 0 in. When I plug my 0 in here, x plus 0 is x. What's delta x plus delta x? 2. So it's 1 over 2 delta x. And that's my derivative. Right? It seemed a little tricky because you had to multiply by conjugate. But I was just seeing if you remember how to do it. Now, step 4, find the slopes of these graphs. So what you have to do now is you just plug in the x values, and that will tell you what the actual slope is of the graph. So at point 1, 1, our x value is 1. So we take 1 and we plug it in here. 1 over 2, radical 1. 1 over 2 times 1 is 1/2. At point 4, 2, our x value is 4. All right? 1 over 2 times radical 4. Square root of 4 is 2. 1 over 2 times 2 is 1/4. And that's our answer. That's it. If I had a point here, 9, 3, it'd be 1 over 2 times radical 9. 1 over 2 times 3, 1/6. Okay, so you could do it for each point. Got it? All right. Another fun fact. Another fun fact, right? An alternate way to find a derivative. All right. I kind of alluded to this before when I gave you the C thing. This is what I actually meant. So first step is to find f of x, which is given. Find f of c. So you're going to plug in a c for your x. So whatever your f of x was, you just put in c's for the x's. Then you plug it into the equation, f of x minus f of c over x minus c. X and c just stay how they are. These are the two things you found up here. You simplify by subtracting and cancel out, as we did before. You're going to factor out the numerator. Whatever the numerator is, you're going to factor out. And then you're going to cancel some stuff out. All right? Oh, sorry. Factor stuff out of the numerator, and then you're going to cancel some stuff out. And then your final step is you're going to plug in your c for whatever your x is left at, and you won't get 0 as the denominator, hopefully. All right? There you go, right? Because this is CF of C, this is the point right here. So this is as x approaches C, the secant line approaches the tangent line. So you're kind of like meshing the secant line and tangent line together in order to do this. Now, find the slope of the tangent of the function using the alternate method. Once again, whatever the method you like is fine. You get the same answer either way. So first one, f of x is given. f of c, we just replace this x with the c, so it's 3 minus 5c. All right? Plug it into this equation. 3 minus 5x over 3 minus 5c over x minus c. 3 minus 3 cancels out. All right? Simplify, leaving you with negative 5x plus 5c, minus a negative is a plus, over x minus c. What can we take out of this equation? So we can cancel out the numerator. We could take out, not a 5, but to switch both sides, a negative 5. So if we factor out a negative 5, you'll have x minus c over x minus c. They cancel out, leaving you with the answer of negative 5. The limit of negative 5 as x approaches anything is negative 5 will be your answer. All right? Hopefully that's okay with you. Let's go try another one. Now, what we're going to do is we're going to do this both ways, all right, and see which way you like better. Got it? Once again, up to you. First way, g of x. F of x, g of x, same thing. Doesn't matter what's in front, as long as you have the of x. 3 of x plus 6. Here. What do we do? This is the original way. G of x plus delta x. Plug x plus delta x in there. 3 halves x plus delta x. 3 halves times x is 3 half x plus 3 halves delta x plus 16. Our original method told us to do this. Subtract that. Right? Cancels out. Cancels out. 3 halves delta x over delta x. The delta x's cancel out, leaving you with the limit of 3 halves as x approaches 0, which is 3 halves. That was the original one. This is the alternate method. Your g of x is the original equation. Same step. G of c. Instead of an x, we plug in a c. Okay? F of x minus f of c. That minus that. Over x minus c. 16 minus 16 cancels out, leaving you with 3 halves x minus 3 halves c over x minus c. I see an x minus c here, so I just take out a 3 halves. X minus c's cancel out. Leaving with the limit as x approaches c of 3 halves. There's no c's to plug in, so my answer is 3 halves. Notice both of them give you the same answer. You just get them different ways. Now this method's okay when you have a smaller x, but when you raise it to higher degrees, it gets a little tricky. This method is the one I prefer, but I'm going to do the same problem with both these ways as well. Right? Usually about 1 out of 25 students prefers this way. It's weird. You're not weird if you do. It's weird that no one really likes it. All right, so first one, f of x is the original equation. F of c, this is the alternate method, is c squared minus 9. We're going to plug it into this equation. X squared minus 9, c squared minus 9 over x minus c. Negative 9 minus 9 is canceled out, so you're left with x squared minus c squared over x minus c. Now, a squared minus b squared is a minus b over a plus b. Same thing here. This is why this way gets tricky, because you always have to try to find x minus c. So this is x minus c, x plus c, over x minus c. The x minus c's cancel out. The limit of x plus c as x approaches c. Now, wherever you see an x, you're going to plug in a c. So, c plus c is 2 c's. All right? This way. F of x, the original equation. F of x plus delta x plus delta x squared minus 9. X squared plus 2x delta x plus delta x squared minus 9. Nothing cancels out. This minus this over delta x. X squareds cancel out. 9's cancel out. This and this over delta x. Cancels out, left with the delta x here. The limit as delta x approaches 0 of 2x plus delta x. Take your 0, plug it in there. Negative 2x minus 0 is 2x. Notice this has a c that has an x. They're both the x values, so it doesn't really matter. When you actually plug in your points, it comes out the same. But you have the same answer. All right? I'm going to go away from using this method just because I don't like it personally, and I'm not going to do every problem twice. So I'm going to stick with this one, but if you prefer to do this one, I can always show if you're right or wrong. Like I said before, it gets a little crazy the higher up you go. So that's the alternate method. Like I said before, if you really like it, you can keep on using it. If you don't, good, I don't use it anyway. All right, here we go. 10 more slides to go. G of x, we're going back to regular derivatives. Original equation. G of x plus delta x. 6 minus, that stuff squared. Replace with this. Now this minus x squared minus 2x delta x minus delta x squared. Got it? This minus this over delta x. 6 cancel out. X squareds cancel out. Negative 2x delta x minus delta x squared over delta x. Cancels out, leaving you with the delta x. The limit of negative 2x minus delta x, this becomes a 0. The limit of negative 2x minus 0 is negative 2x. Right? And we're going to find a way where you can solve this pretty much in like 15 seconds in future chapters. But for now, I want you guys using these formulas to solve it. All right? I know there's an easier way to solve it. I can solve these right off the bat. Answer to this one is 3 minus 2x. Ready? You want to see how I found that out? Actually, 15 seconds. It takes like 1.5 seconds. All right, so ready? Let's see if I'm right. 3 minus 2x. F of x is the original equation. F of x plus delta x. 3x plus delta x minus x plus delta x squared. 3x plus 3 delta x minus x squared, 2x delta x squared. These minuses all get distributed in there. So you're left with negative x squared plus 3x plus 3 delta x minus 2x delta x squared minus delta x. I just like to put the x squareds up front. That's the only reason that's out there. Doesn't matter what order you put the stuff in, because when you finish it up, it's all going to be in the end. This minus this over delta x. 3x's cancel out. There you go. The minus delta x's cancel out anyway. 3 delta x minus 2 delta x minus delta x squared over delta x. Cancels out. Cancels out. One of these two cancel out. So you're left with the 3 minus 2x minus delta x. That becomes a 0. 3 minus 2x minus 0 is 3 minus 2x, which is your derivative. That's your answer. All right? Ready for another? Or, if you want to put this in the correct order, negative 2x plus 3. Which one's better? It doesn't matter. 18. Go. We're going to up the levels of this. H of x is the original equation. X plus delta x squared plus 3. X squared plus 2x delta x plus delta x squared plus 3. Nothing combines here anyway. That minus that. X squareds go away. 3's go away. 2x delta x plus delta x squared over delta x. So these get canceled out. You're left with 1 delta x over there. So you got 2x plus delta x. 0 goes in there. 2x plus 0. Your answer is 2x. Right? Oh, I didn't even show you how correct that was on another problem. Oh well. You can go back and check my answer. Alright, next one. Why don't you guys attempt? Problems 19 and 20. These are two easy problems. I gotta run and throw a quick charge on my computer before things go really bad. Alright, did you get your answer yet? There we go. Alright, so these are tricky. Even though they seem very easy, they're actually quite difficult. But they're not. For 19 to 20, we're just going to bust out the rest of these. So, what's the derivative of 7? Well, f of x equals 7. What's f of x plus delta x? Well, there's no x to plug this into, so the answer is still 7. Based on this equation, 7 minus 7 over delta x, right? What's 7 minus 7? 0. 0 divided by delta x is 0. 0 divided by anything is 0. So you don't really have to plug in your delta x here. Your answer is 0. Right? You would just do 0 divided by this before you plug your 0 in. Otherwise, your answer would be undefined. Problem 20. What do you got? Same as there. F of x is negative 3. F of x plus delta x is also negative 3. Negative 3 minus negative 3 is negative 3 plus 3, which is 0. 0 divided by anything is 0. The limit of anything approaching anything of 0 is 0. We good? Good. All right, problem 21. f of x, negative 10x. F of x plus delta x, negative 10 times x plus delta x. Negative 10x minus 10 delta x. Okay? Negative x, negative 10x minus 10 delta x minus negative 10x. Cancels out, leaving you with a negative 10 delta x over delta x. Cancels out, leaving you with the limit of negative 10 as delta x approaches 0, which is obviously negative 10. All right? 3. 3x plus 2, 3 times x plus delta x plus 2. 3x plus 3 delta x plus 2. When you do this, 3x's cancel out, the 2's cancel out, leaving you with 3 delta x over delta x. Its limit is x, delta x approaches 0. And limit of 3, and your answer is 3. Told you. Easy? Of course they are. Will these get more difficult? Of course they will. These are the easy problems. All right. 2/3. F of x is 3 plus 2/3 x. 3 plus 2/3 x plus delta x. 3 plus 2/3 x plus 2/3 delta x. 3's cancel out. 2/3 x's cancel out, leaving you with 2/3 delta x over delta x. Delta x's cancel out. Limit of 2/3 is x delta x approaches 0, so your answer is 2/3. I told you. 2x plus 1. F of x is x squared plus x minus 3. X plus delta x squared plus x plus delta x minus 3. Expand this. X squared plus x, 2x delta x plus delta x squared plus x plus delta x minus 3. Guess what? None of these things, none of these 6 pieces combined, they all have different variables attached. So it's this 6 things minus those 3 over delta x. How much happens? Delta x's cancel out. X's cancel out. Oops, negative 3's cancel out. X's cancel out. I don't know why I went out of order there. That's weird. Leaving me with 1, 2, 3. 2x delta x plus delta x squared plus delta x divided by delta x. Cancels out. 1 of the 2 cancel out. All cancels out. All cancels out. When I say all cancels out, I mean they cancel out and they're left with a 1. Oh, there you go. 1. And when you do delta x divided by delta x, you got to make sure you put a 1 back there. You just can't let it go, or else technically that's a 0. Because 2 times 1 is 1. 1 on the bottom is still a 1, okay? But if it's delta x divided by delta x, you got to leave a 1 up there. So it's 2x plus delta x plus 1. This delta x becomes a 0. 2x plus 0 plus 1 is 2x plus 1. All right. Ready to take it up a level? 25. I like this one. I like problems where you can only fit one problem on the page. Think 4 more problems. F of x is the original equation, x cubed minus 12x. F of x plus delta x is x plus delta x cubed minus 12 times x plus delta x. This cubed, as I said before.
I'm not sure.
It's okay. This cubed plus 3a squared b plus 3ab squared plus b cubed. This just becomes that. Minus 12x minus 12 delta x. None of this stuff combines. You can check it, double check it. I'm not lying to you. This minus this. So the x cubed will be an x cubed that cancels out here, and there'll be a 12x that cancels out here, minus 12x. The rest is 1, 2, 3, 4 pieces, all stay. 3x squared delta x plus 3x delta x squared plus delta x cubed minus 12 delta x over delta x. Cancels out. 1 of the 2 cancel out, 1 of the 3 cancel out, cancels out, and cancels out. 3x squared plus 3x delta x squared minus 12. 0 and 0. So you're left with the 3x squared plus 0 plus 0. So 3x squared minus 12 is final answer. All right. 26. You're done already. Good. F of x, original equation. F of x plus delta x. X plus delta x cubed plus x plus delta x squared. That stuff plus that stuff. Now, how much of this do you think is combined? Actually, if you really look close to it, none of these are the same. Kind of amazing. This 1, 2, 3, 4, 5, 6, 7 things minus these two over delta x. X cubes cancel out, x squareds cancel out. So you have 1, 2, 3, 4, 5. 5 things. 3x squared delta x plus 3x delta x squared plus delta x cubed plus 2x delta x plus delta x squared all over delta x. Because these all have delta x's, that's good. You want them all to have at least 1. So we can cancel out the denominator. Cancels out all the way, left with 1, left with 2, all of it, left with 1, all of it. 3x squared plus 3x delta x plus delta x squared plus 2x plus delta x. Put in a 0, and a 0. Okay? The 0, 0, and zeros all cancel out, become 0, so you're left with 3x squared plus 2x. Final answer. All right? 27. Uh-oh, a fraction. No one likes fractions. That's not true. I don't mind fractions. What do we got here? What do we got? All right, so f of x is 2 over x plus 1. This is 2 over x plus delta x minus 1. Oh. 2x plus delta x minus 1 minus 2 over x minus 1. Shoot. How do we do this? Well, how do we subtract fractions? You have to find a common denominator. How do you find a common denominator? You multiply by both denominators. So if I multiply both of these, and you have to, whatever you do at the top, you have to do at the bottom. X plus delta x minus 1 times x minus 1. So if I multiply by the numerator, I have to do the denominator, so I'm technically multiplying by 1. This becomes 2 x squared minus 2. So what does that mean? This, all right, cancels out with this bottom piece, right? Got it? Leaving with 2 x minus 1 minus 2, ready? X, 2 delta x minus 2, all right, and this cancels out with the bottom piece. Over this stuff, right, over delta x. Got it? Keep the minus. Now, I should have put this over 1 to make it look better. So technically this is over 1 because the top is all getting multiplied by that. So 2x minus 2x cancels out. Negative 2 minus negative 2 cancels out. And you're left with 2 delta x over x plus delta x plus 1, x minus 1, all over delta x. Now, if you remember my rules about a fraction over a fraction, these guys jump down to the denominator, okay? Because you can't, technically it's 2 delta x times delta, divided by x delta x minus 1 times x minus 1 times the reciprocal of this, which is 1 over delta x, right? Cancels out, leaving with 2 over all that stuff. Now you plug this in for delta x, you only have 1. So x plus 0 minus 1 is just x minus 1. So it's 2 over x minus 1 times x minus 1. X minus 1 times x minus 1 is x minus 1 squared. 2 over x minus 1 squared. Final answer. All that work just to square this bottom piece. Ridiculous. Ready? Last one. Breathe. Breathe, breathe, breathe. Where are we at? 28. A radical. F of x equals radical x minus plus 4. X plus delta x plus 4. This minus this over delta x. Do you remember how we do this? We multiply by the, one last time, the conjugate. This plus this over that plus that, over 1. Okay? If you want to do it like this, it's fine, or you can just put it on the bottom. Like I said before, it doesn't matter. So, cancels out, leaving with x plus delta x plus 4. The middle pieces, this times a positive, this times a negative, so the middle pieces are always going to cancel out. And then you're left with x plus 4 on the back end, and you're left with this over this, right? All over delta x. If you want to move this down to the bottom right away, you can. So you can either keep it there and move it, or just move it right away. Anyway, x minus x cancels out. Oops, sorry, I reduced this first. Now x minus x cancels out. 4 minus 4 cancels out. Leaving you with delta x over all this stuff over delta x. Now, if you want, you can move it. It's up to you when you want to move this to the denominator. You can move it right away. You could wait. It doesn't matter. The key here is the delta x's cancel out, leaving me with a 1 all over all this stuff. Okay, because remember, 1 is the placeholder. Type in 0 for delta x. 1 over x plus 4, radical x plus 4, radical x plus 4. Radical x plus 4 plus radical x plus 4, how many do I have? I have 2. So it's 1 over 2 square root of x plus 4. And that's the derivative of this equation. So g prime x equals this stuff. All right? So, about an hour and a half. That's not too terrible. We were able to discuss the derivative and the tangent line problem. So we went over the tangent line problems, how to use the tangent line problems to find the derivative problems, and that all originated from finding the secant line type problems. So hopefully now you guys are able to find derivatives using the derivative equation, and eventually we will be able to do this a lot quicker using shortcut methods and other types of rules. All right, so to the next time, glad I could be of help to you today, and have a good day.